Hello everyone, it's time to do another Leetcode problem, and the problem that we are going to discuss today is problem 271, encode and decode strings. Okay, so let's take a look at the description of the problem. So what we have to do is we have to design an algorithm to encode a list of strings to a single string, and that encoded string is then sent over the network and decoded back to the original list of strings. Okay, so we have to implement two methods or two functions. The first one will take an array of strings or a list of strings, and then it will encode it into a single string. You can see this is the encoded string, and that encoded string is actually sent over the network to somewhere, right? So, and there is a decode function there, and that function should be able to return a list. That list has to be equal to the original input strings, right? Okay, so for example, say my input is two strings, hello and world. This list has two strings, and somehow, okay, anyways, we have to encode it, and that will change it to this single string message. Okay, and then it's sent somewhere, and there should be another method, decode. That decode should take this encoded string and decode it back to the original one. So decode it back to the original list. Okay, so how do we do this problem? Before doing this problem, let's see, we have to be careful. Like, obviously we have to ask the interviewer that what kind of characters can be in the strings, and here it says that the strings can contain any possible character out of 256 valid ASCII characters, right? So that is important. So how do we solve this problem? As the constraint says that only the ASCII characters are the valid characters. So what if we just do this? Say hello, this was our input, right? And then world. So we can actually read, say this one has n characters, right? In total, like all the strings here, let's say have n characters. So what if we do this? We just start reading from each string, right? So we read it, and then we add, once a string is done, is read, we can add a non-ASCII character here. So non-ASCII character, right? Non-ASCII character, and then so that non-ASCII character is going to uh, make a difference. Like it will work as the delimiter, right? So a non-ASCII character can be, say, it can be pi, right? So no, pi is a non-ASCII character, right? So what's going to happen is this is going to be the encoded string, right? So the encoded string, or if my and then once I get this, I want to decode, so I will start reading it again, and then until I get like that character pi, I will keep on adding to the current string, and then as soon as I find this, then I will start reading the next one. Okay. Okay, so that's simple. Given the constraint that we have only ASCII character, 256 ASCII characters are valid in the input. So what is the time complexity if we do this? So for encoding, you can see what we are doing is we are actually reading all in characters, and as soon as a string is like, we read one string, after that we just add one non-ASCII character, right? Okay, so eventually we are reading actually in order of n strings, right? And just adding the non-ASCII characters. And for the decoding, you can see we are again reading from this, right? So this is also order of n. So decoding is also order of n. And the space is like, say, if we have like k words, if we have like k words or k strings, in that case, we need like order of k, this delimiter character pi, right? We need this k times to join all these strings. Okay, just for another example, say my name is, so if my input is, say, my name is John, right? If that is my input, the encoded string is going to be my pi name pi is by John. Okay, so that's going to be the encoded string. And the decode function is going to decode it. So I will read it again, my, and then I find this pi. So that means I know that that's the end of the first string. Next, I keep on reading, and then I find this pi. I end the next string, then I find this pi. I end the next string, and finally, John. Now, as you can see, we have a follow-up question. Could you write this generalized algorithm to work on any possible set of characters? Okay, so can we do that? So in that case, we can actually use the chunked data transfer technique. So if you know about the data communication or how the packets are being transferred over the internet, data packets, right? You know that the data packets actually have two parts. The first part is a header, and the second part is the data, something like that. So this is not as simple as this, but this is the basic idea. So basically, we send this, say a client send this to the server, and the server immediately knows, okay, it can read the header, and then it can extract the data from the next part. So the idea here is, what if we have something like this? Say my input was hello, right? And then it was world. So what if we make a self-contained data chunk? So what we can do is we can start reading from here and see that the length of this is 5, right? So we add 5, hello, and then next we keep on reading again and see that the next word is also 5. So we add 5 and then put world, right? So what if this is the encoded string? Can we decode it? Yes, we can decode it, because what we can do is when we're decoding, we can just read 5, and then we know that, okay, next 5 characters are actually the part of this string. So you can read the next 5 characters, and then again we read 5, and we know that the next 5 characters are also another string, right? So we keep on doing this until we reach the end. Now there is a problem in this approach. The problem is, say my input was, say if my input is something like this, instead of hello world, it's hello 5 world, right? If that is the case, in this case, what will happen is my encoded string is going to be something like this: 5 hello, and then 5, sorry, this will have a length of 6, right? Okay, so it will be 6, and then I will add the string 6 5 world, right? Now the problem here is, when I'm decoding, yes, I'm fine with this, that okay, next 5 characters create the first string, but now it will fail because I don't know whether I have to take 6 or 65, right? So there is no way to differentiate between this 6 and this 5. This 5 was actually part of the original string. Okay, so the solution for that is I have to add a further delimiter. So instead of just 5 hello, let's add another delimiter. So it's 5, and then let's say add another delimiter hash and hello, and then 6 hash 5 world. Okay. So next, what I am going to do is I will keep on reading until I reach a hash. So I reach a hash, then I immediately know that I'm done. The length is 5. So I read 5 characters. So I read 5 characters, know that this is the first string. And then again, I keep on reading. I read 6. Okay. And then I find hash. As soon as find hash, I know that, okay, there are 6 more characters which all belong to the same string. So I read the next 6 characters. Okay. Now you may have a question that, okay, what if the input has something like this, hello, and then say it has something 5 hash world, right? In that case, what's going to happen? Well, there is no issue. See here, I read this, I see that the length is 5. So my encoded string is going to be 5 hello. And then I read this, I see this length is 1, 2, 3, 4, 5, 6, 7. So I put 7 and then hash and then 5 word, right? So this is going to be my encoded string. Now, when I'm going to decode, first I will read 5, then hash, then I know that my first string is going to be of length 5. And then I read 7, and then I get hash. So I read 7 and I get hash. So I know that next I have to read all 7 characters, right? So basically, I will never go and read this 5, 7 and get confused, because immediately after this, I know that the rest of the 7 characters, immediately after I find this, I know that the length is 7 and the rest 7 characters are actually part of this string. Okay. So this is the idea. Just get the length for each string and then use a delimiter. It can be this, or you can use other delimiters. So this is simple. And for the encoding, you can see what we are doing is we are just reading the strings character by character. So if there are like n characters in this input, then the encoding is taking actually order of n. What we are doing is just we are reading the characters and adding some extra characters and making it one string, right? Okay, so encoding and decoding. For the decoding, what we are doing is we are again, so this is also order of n characters in the encoded string. For the decoding, I'm just reading this order of n characters and just making substrings out of that. So that's also order of n, right? So I'm just reading this order of n characters and decoding from it. And only extra space I'm using is these ones, right? The numbers and some delimiters. So we can say we are using the space is order of k. That is the extra numbers that extra characters that we are adding due to the length of the string and the delimiters. Let's take a look at the code. We are using a string builder class, and then reading from the input strings, we are first taking the length of the string and then appending a hash, that's the delimiter, and finally appending the actual string, right? Okay, so we are keeping on doing this, and finally everything has been added to this string builder. So we return string builder dot to string. That's one single string that is being returned by the encode method, right? This is the order of n. procedure where the number of characters in all the string in all the strings is together n. Okay, so when decoding, we have this single string, and so we'll have to return a list of decoded strings, right? Okay, so we start from index I. Obviously, we'll read each character, and we'll keep on reading until we reach the end of this single string, right? Okay, and then we have to first read the length of the current string, right? So uh, we start with j equals to 0, and then uh, we'll check until the character at I plus j is not a hash, that is we used as a delimiter, right? As soon as this is hash, we know that okay, I have to stop increasing j, right? So that means starting from here up to here, it's all numbers, and it denotes the length of the next string. Okay, so we get the length how? Starting from I up to I plus j, we get the substring, and this one gives me the length value of the next string, as I had explained in the explanation. And next, for the decoded part, I know the length, right? And then I have to start at I plus j plus 1. The reason for that is I plus j character is this hash, right? This is the I plus jth character. So I start from the next character from the hash and take the amount of length and take that substring and add that substring into the decoded list. Okay. Okay, so we are done. Next, what we do is I have to look for the next string in the list, right? So I have to start reading again where it ended here, right? So it ended here. I just add. So that is the okay. So it ended, the Java function, right? It ended actually here. So the next I starts from here. Okay, I plus j plus 1 plus length. And finally, everything is added to the decoded list, so it return decoded. Okay, so hopefully you understood the concept, and thanks for watching. We'll come back with another problem, and please subscribe to the channel and press the like button if you liked the explanation. Thank you very much.